Hey there, class. We're here today to look at the idea of a component, and specifically here, what a vector component is. So what I'm going to do is I'm going to switch over to a little simulation that I like to use from PhET, and basically kind of want to introduce the idea of a component to you. So what I can do here is I can take a vector, and in this case I'm going to take the vector A and I'm going to drag it out and I'm going to place it here on the origin. Now you'll notice a couple things here I want to point out is that right now the components are being shown, and the components are these two little dotted arrows that are right here and right here. I can display those components differently. I can display them so that one ends up on the x-axis and one ends up on the y-axis. And I can display them this way so that they end up just off a little bit so you can see them better. I'm going to stick to this convention right here, and I'm also going to have the values come up as well as the angle show right here like this. So here's what I'd like to do. I'd like to talk to you a little bit about the idea of vector components. This right here is the vector A. The vector A has an x component and it also has a y component. Now what I'm going to do is I'm going to take this vector and I'm going to drag it up so that its end ends up at 20, 20, and I'd like you to make a prediction. What do you expect the components to look like? Okay, so notice I went over to 20, 20, and you'll notice that each component itself is 20 and 20 units, whatever the units might be here, and that it is at an angle of 45 degrees for the actual vector itself. So the vector has a magnitude of 28.3 and a direction of 45 degrees above this x-axis. And in previous videos, we've talked a little bit about how we can define that. So today we're looking really at this idea of a component. So I'm going to change my vector yet again. I'm going to take this vector and I'm going to, let's say I'm going to go over to this point right here. So it's going to start at the origin and it's going to go over to the point, I guess that's what, 25, and this number's covered up. I can't see it. And this looks like a 10 over here. So I'm going to go to 25 and 10. What do you expect the components to look like? Okay, so notice here that our x component goes over from the origin to the 25, and that our y component goes from the origin up to 10. So you'll notice that, when we put the end of the vector here, that the components themselves are almost like the coordinates of this end point right here, aren't they? The length of this vector has a magnitude of 25 units, and the length of this vector component has a magnitude of 10 units here as well. And then to get the magnitude of our overall vector, from a previous video, we learned that we could take two vectors and combine them, and we drew them more like this in a previous video. This is something called the tip-to-tail method. But basically, we could take this and this, because they were at a right angle with one another. We could use the Pythagorean theorem to find the side that's called the hypotenuse, or in this case, the resultant vector, which is the vector we're looking at. So in some respects, I want you to think about vector components are simply two vectors that can be put together that make a third vector, that resultant vector. It's just we need to think backwards now. We basically are saying what two vectors, one that's along the x-axis and one that's along the y-axis, can add together to give us the vector we're looking at. So let me flip back over to where I have our notes. I'm going to scroll down here and let's take a look at an example. So we have a vector here. I have it on a northeast, south, and west. Of course, we could call this the plus y, and we could call this the plus x. This would be the minus y, and the minus x, right? So if I want to draw the components of this, what I'm going to do is I'm going to draw a dotted line down here. That's not the vector itself. This is the vector. I'm going to start it back here, and I'm going to draw it out to this point right here. And this is what I'm going to label as the AX component, or I could say the X component of the vector A. And likewise, the Y component is going to be drawn like this. I'm going to draw a line over here, and I'm going to draw the component in. Okay, it's hard for me to draw a vertical line on my pad here, but basically it's going to look something like this. Or this will be called the Y component of the vector A. Okay, now a couple little details that I want to point out. When you're drawing these components, there are some red flags that I'd like you to look out for. The first red flag is drawing the components at right angles to the vector. That's a big no-no. Let me show you what I'm talking about. Okay, so in red flag number 1, what I will often see students do that is incorrect is they want to make the right angle right here, and they want to draw the component up to the side of the Y component like this. Okay, the right angle is not in this location. The right angle should actually be over on the Y-axis. So that's the first mistake I see. Red flag number 2 is drawing components at just random angles, where we're not really sure where the angle should be, and we just simply draw them at some random angle. So what I'll see sometimes is a student just draw this like, oh, I think it's supposed to be kind of along this line. That actually looks like a 90-degree angle. Let me draw something that's not quite 90, like something like this. Okay, this, of course, right in here is not a 90-degree angle, and nor is this right down here a 90-degree angle. And so they'll draw that as a component. The third thing that I see is drawing components at the incorrect length, and that would kind of go along with what I've described here. This vector that you see on the y-axis is certainly not the correct length at all. And if I were to complete what I often see from students here, where they would call this the x component of A. Oh, look at that, it got rid of my arrows. Well, that's another big one that I see. I'll often see students forget to draw the arrow points there. But basically, one of the mistakes I often see is the magnitude not being drawn correctly. And one of the other big red flags that I see is components that are not drawn as vectors. So let me bring up a different color here. Let's use green. And let's say this is my vector. Let's call it the vector B. What I'll often see students do is I'll simply see students draw something like this and say, I've drawn the components. And I would say, you haven't drawn the components. Where are the components? Components are vectors too. And again, we've talked in detail about this, but vectors have to have two things. 1, magnitude, and 2, direction. This drawing over here doesn't show me anything about magnitude or direction. So if I were to truly do this properly, okay, let me make sure that we get this properly done. When we draw the component, we need to make sure that this little dotted line comes over and it makes a right angle with the axis. It's making a right angle with the axis. Second thing I want to make sure is that I'm drawing from the origin of my vector. In this case, it's truly the origin of my axes. And I put an arrow point on the end of it. Okay, this is telling me that it's this size, it is this length, and it has this direction, as we note here with the arrow point. This would be, of course, the y component of B. Likewise, when I draw the x component, I'm drawing it here, and that would be labeled as the x component of B. Notice once again there's a very clear length to it. That's the magnitude. And then this arrow point on the end shows me that there's a clear direction.